All right, so we're going to be looking at mole ratios and solving questions using the coefficients from a balanced reaction and solving for moles of one chemical given moles of another. Okay, so the first thing I want to look at then is this reaction. So N2 plus 3H2 yields 2 NH3. So what we're going to do is focus on these coefficients because like we've seen, it's a ratio. This is all about ratios, okay? We know that we can write ratios in 3 ways. We can use a colon, a fraction, or the word to. And so we're going to be looking in the beginning using colons, but then when we start solving, we're going to use fractions, okay? But we know that it's just a ratio. It's a relationship between things. This reaction will only ever occur in this set ratio. 1 molecule of N2 for 3 molecules of H2 makes 2 molecules of NH3. Okay, now, what if I said instead of 1, 3, and 2 molecules, what if I said 100 molecules of N2 for 300 molecules of H2 makes 200 molecules of NH3? Is that the same ratio? Does it still reduce to 1 to 3 to 2? Yeah, okay. Well then, what if I said a mole? So remember the mole is 6.02 times 10 to the 23 atoms or molecules, right? It's a counting number. It's the same as almost saying like a dozen, just a whole lot more. So now what if I said 1 mole of N2 for every 3 moles of H2 for every 2 moles of NH3 is formed? It's the air conditioner. So it's the same ratio. It's still a 1 to 3 to 2, okay? I can also pull out different ratios from this. Instead of 1 to 3 to 2, I can say 1 and 2 is needed for every 3 moles of H2. I could also say 3 moles of H2 is needed to make 2 moles of NH3. Or I could say 2 moles of NH3 is produced from 1 mole of N2. You can use the coefficients to say any relationship between any of the reactants and products in the reaction, okay? So let's take a look at this then in terms of number 1. So for every 1 mole of N2, so if I'm looking at N2, 1 mole of N2, blank moles of NH3 are formed. So what's this ratio? 1 to 2. Okay, so for every 1 mole of N2, 2 moles of NH3 are formed. That's the ratio. It's a 1 to 2 ratio. Okay, well now let's look at number 2. To react 6 moles of H2, blank moles of N2 are needed. Okay, so let's pull this out for a second. I'm comparing H2 to N2. So if I just look at the coefficients from the balanced reaction, and I'm just comparing hydrogen to nitrogen, I'm saying that I need 3 moles of hydrogen for every 1 mole of nitrogen. Okay, that's the ratio from the coefficients from the balanced reaction. But the question here is saying, but instead of reacting 3 moles, what if I reacted 6 moles? Turn to a neighbor and tell them how many N2s would that be? Okay, well, it's a 3 to 1 ratio, right? And it will only ever exist as a 3 to 1 ratio. So if I have 6 H2, 6 moles of H2, then how many moles of N2 are you going to need? 2. A 3 to 1 ratio is the same as a 6 to 2 ratio. It's the same. Same ratio. Okay, so then look at number 3 then. To form 12 moles of NH3, blank moles of H2 and blank moles of N2 are needed. So let's look and see what this means. I'm comparing NH3 to H2 to N2. So if I just look at the coefficients from the balanced reaction for this ratio, 2 moles of NH3 are produced from 3 moles of H2 for every 1 mole of N2. Okay, and in the question, it says, well, what if you're forming 12 moles then of NH3? Thinking, how much of the other stuff are you going to need? Turn to your neighbor and tell them how much of the other stuff are you going to need? Okay, well, if the ratio of the coefficients of the balanced equation is 2 to 3 to 1, if I am producing 12 moles of NH3, how many moles of H2 am I going to need to make that happen? 18. 2 times 6 is 12, right? So 3 times 6 is 18, and that means 1 times 6 is how many? 6. So this 2 to 3 to 1 is the same as a 12 to 18 to 6. It's the same ratio. It reduces to 2 to 3 to 1. Okay? So to form 12 moles of NH3, 18 moles of H2, and 6 moles of N2 are needed. Okay, we can do it like this because these are really pretty numbers. They're nice and whole, pretty numbers. But we know in reality, that's not realistic, okay? It's hardly ever pretty whole numbers, like 99% of the time, okay? So we need to solve these using this idea of ratios without just multiplying by 6 or multiplying by 2, okay? And we can do that using train tracks. So again, train tracks, you're gonna see other people do it as parentheses with fractions, but it's the same concept. Instead of doing a train track, it's just a parentheses and another parentheses that are being multiplied together. Okay, so as a refresher, a reminder, our train is whatever we're given, okay, in this case, our value in moles, and then you're gonna multiply that by the mole ratio, which comes from the coefficients of the balanced reaction, with whatever chemical you want on the top, and whatever chemical you're given or trying to cancel on the bottom. So let's look at number 4. I'm also going to show you a strategy. Okay, we have used it before, but just as a reminder that you can use in this, that I want you to use in this class, and that will work in any of your other classes also, okay? So, question number 4. How many moles of NH3 will be formed if 7.35 moles of H2 react? Okay, what are you given? 7.35 moles of H2, so underline it. And what are you trying to find? Moles of NH3, so circle it. As we go through this unit and in stoichiometry, the hardest part is figuring out what you're starting with and where you're trying to go, okay? And then how you get there. The math is not hard. It's multiplying and dividing. It's what it means and the steps that you take to get there, that's the most challenging part. Okay, so if I have a train track set up, my train is my given in this top left box. 7.35 moles H2. That's what I'm given. That's what I'm starting with. That's my train. Okay. Now I need to think about the next part, because the next part is the ratio. All right, the same way we did up here where we multiplied by 6, or here where you saw it multiplied by 2, okay? We need to figure this out because it's not a simple whole number. So in math, okay, in math, if you have x over x, what happens to those? They cancel. Okay, so just the same way in chemistry, your units will cancel also. So if you have moles of H2 over moles of H2, what happens to those? They're going to cancel the same way x over x does, okay? So if I'm wanting the mole to cancel, I have it as a numerator here, so I'm going to need it to be a denominator, so it will cancel. So your moles of H2 and your moles of H2 will cancel just like here, just like x over x in math, or 2 over 2. Okay, well then what goes on the top? What am I looking for? So moles of NH3 is going to be on the top. Because that's what I want. I'm trying to cancel moles of H2. I want moles of NH3, so that's on the top. Now, where do the numbers come from? This is the ratio. okay? We know that in this reaction, it will only ever react in known quantities in a known ratio. That is why we balance it to start, okay? So this whole thing right here is the mole ratio. And this comes from the coefficient of the balanced reaction. So looking at the coefficients of the balanced reaction, what number would be on the top with moles of NH3? 2, because it's 2 moles of NH3 for every 3 moles of H2. It's the coefficients from the balanced reaction. It's a 2 to 3 ratio. Okay, now we're ready to solve. Moles of H2 cancel, because one's on the numerator, one's on the denominator. And just like in math, we're going to multiply across the top with our numerators, and we're going to divide out 3 as our denominator. So put this in your calculator, and when you get an answer, hold your calculator in the air. You gotta do that muscle memory and not on your phone, on an actual calculator. When you get an answer, hold your calculator in the air. All right. Okay, we are not going to worry about significant figures. I just want us to be able to solve the problem. Okay, so typically when I ask you for an answer, I'm looking for 2 decimal places, going to 2 decimal places. If it only has 1, that's okay, it only has 1. So what's the answer here? 4.9. Okay, 4.9 what? Cheeseburgers? Sour Patch Kids?
Yeah.
Mole of NH3. Okay, so here's a couple of things. Number 1, if you just write 4.9, it's wrong. 4.9 what? 4.9 bicycles? I don't know, you didn't tell me. Okay, if you just write 4.9 moles, it's wrong. 4.9 moles of what? Hydrogen, nitrogen, ammonia. You have to have the number, the unit, and the chemical for it to be correct. Okay, the other thing is that, what does this mean? Okay, so let's say that you are a scientist and you're working in a lab, and your boss comes in and says, okay, we've got 7.35 moles of H2 of supplies. How many moles of NH3 can you make from that? This kind of reaction or this kind of calculation is what you would do to solve that problem. Okay, now we know in the real world it wouldn't be exactly 4.9 because there is experimental error and things that can happen, but this is what you would get from that calculation. Okay, let's look at the next reaction. Fe2O3 plus 3CO yields 2Fe plus 3CO2. So we're looking again at the coefficients from the balanced reaction, which tells us our ratio. So number 5, for every blank moles of Fe2O3, blank moles of CO2 are formed. What goes in here? What's that ratio?
1.
So for every 1 mole of Fe2O3, 3 moles of CO2 are formed. We got that from the coefficients of the balanced reaction. Look at a neighbor and say coefficients of the balanced reaction. There it is. Okay, so number 6. If 9 moles of CO react, blank moles of Fe will be formed. Okay, well, let's think about this. I'm comparing CO, which is carbon monoxide, to iron. Using the coefficients of the balanced reaction, okay, not the 9 moles, but just the balanced reaction, what is this ratio? 3 moles, there it is, 3 moles of CO for every 2 moles of Fe. Okay, and for this question, I'm saying, but what if we have 9? What if it's 9 moles of CO? In order for this ratio to continue, it has to have the same relationship between the numbers. So 3 to 2 and 9 to 6, okay? Because that's a 3 to 2 ratio. But again, that's a nice pretty whole number. So let's solve it when it's not a nice pretty whole number. So we're going to do the same strategy where we're underlining what we're given, we're going to circle what we want, and then we're going to set up our train tracks. Number 7, how many moles of Fe will be formed from 3.62 moles of CO2? What are you given? Perfect, I'm going to underline it. And what are you trying to find? All right, so the next part is putting in my train. So whatever you're given is going to be your train on your train track in that upper left box. 3.62 mole CO2. Okay, next step, I'm going to copy these units down to my other track, my denominator, so they cancel. That same conversation is up here. X over X, we want them to cancel. And then what unit what did I circle? What am I trying to find? Moles of Fe, so that goes on the top. So once you have your units figured out, then we work in the numbers, okay? So using the coefficients of the balanced reaction, what is the ratio or the relationship between moles of Fe to moles of CO2? So 2 moles of Fe for every 3 moles of CO2. It's a 2 to 3 ratio. So it's a 2 to 3 ratio. Didn't we also say we could write ratios as fractions? This is like a fraction, 2 over 3, right? Okay, so now we can solve. Mole CO2 cancels with mole CO2. We're going to multiply our numerators, 3.62 times 2, and then divide out the denominator, which is 3. When you get an answer, hold your calculator in the air. What's the answer? Good, 2.41 mole Fe. Again, if you just write 2.41, it's wrong. 2.41 what? Slices of pizza? No, moles of Fe. Okay, you need a number, a unit, and a chemical. Okay, now let's look at number 8. There's no setup of the train track given to us, so we're going to do it ourselves. How many moles of CO will react to form 1,083 moles of CO2? What are you given? What are we going to underline? Perfect, moles of CO2. And what are you trying to find? Perfect. Okay, now I'm going to set up a train track. I'm going to put my train in the train box, which is the upper left-hand corner, which is your given. So I'm starting with 1083 moles CO2. Next thing is I'm just going to copy this unit straight down. That is the first step you do because you know that you're going to need that unit to cancel. And the only way it's going to cancel is if it's a denominator. Okay, and then what did you circle? What are you trying to find? Moles of CO, carbon monoxide. All right, so now that I have my units in place, it's a ratio. It's a ratio. So looking at the coefficients of your balanced equation, what is the ratio between moles of CO and moles of CO2? 3 to 3. Okay, and those comes from the coefficients from our balanced reaction. So now we can solve. Mole CO2 cancel. On the top we multiply, on the bottom we divide. But if we look at this, 3 over 3, what is that? 1. So what's this answer? 1083 what? Moles of CO. Okay, so when I'm asking you to show your work, this is what I mean. Right here. I'm asking you to show your work, and this is showing your work. Okay? I recognize that for some of you, you can like just put it in a calculator and get an answer, and I get that. But this is step 1, and we're going to be adding pieces to this. Okay, so we've got to make sure that we have this part down so we can add to it later. All right, so your actual steps, if you look at the very bottom of your page, you write down the given and set up your railroad tracks, transfer the units to from the given to the bottom right corner, meaning you're going to cancel it. Write the units you want on the top, fill in your mole ratio from your balanced equation, cross out any units that cancel, multiply across the top, meaning your numerators, divide around the bottom, meaning your denominator, and then write the answer with the units and the chemical. Okay?